Hi everybody, my name is Marissa Van Munster and I'll be doing my presentation on polymers. So, what are polymers? Polymers are chemical compounds that are formed by long repeating chains of molecules, which is also known as monomers. So monomers could be made of the same kind of repeating molecules, or they could be made of combinations of different kinds of molecules. So, you might not think that you know a lot about polymers, but they're actually involved in your daily life without you even realizing it. So some common examples that you may know of are nylon and polyester, which are made in a lot of your clothing, as well as Teflon, which is found on the non-stick surface of a lot of baking sheets or frying pans. And just some other common examples are plastic wrap, sporting equipment, and food containers. So there's different kinds of polymers. So natural polymers have been around since the beginning of life, while synthetic polymers have been around since about the 20th century. Early 20th century. Natural polymers include cellulose, starch, complex carbohydrates, as well as DNA, surprisingly. So synthetic polymers were created to tailor products that we use in our daily life to give them properties that make them ideal for what we need them for. So most synthetic polymers start from the same material, which is crude oil. But as we know, crude oil is no longer easy to obtain, which kind of makes it an issue. So some examples of the synthetic polymers are the ones that we know more of, like the examples I gave before. So nylon, polyester, Teflon, those are all examples of synthetic polymers. So there's also chemically modified natural polymers and semi-synthetic polymers. So this would include polyethylene and rubber, but I won't be talking about those as much. So something I'd like to address before I jump into the next topic is that polymers and plastics are often thought as interchangeable, which isn't accurate. So polymers include all natural and synthetic polymers, while plastics only account for some synthetic varieties of plastics. So the first topic I would like to talk about is BPA. So BPA stands for bisphenol A, and this is used as an additive to plastics, and its chemical formula is C15H16O2. It is used primarily in the production of polycarbonate plastics as well as epoxy resins. So these products are used in a lot of food containers. Specifically, epoxy resins are used to coat the inside of metal containers. So you might notice that your plastic water bottles that you drink from, on the bottom, you might see the words BPA free, and I will jump to that in a moment as to why they have to say that. So BPA is known to migrate into food and water from these plastic containers being used as food storage. And this has been shown in a lot of studies that if food is stored, then it will migrate. So why is this an issue? Well, BPA is actually an endocrine disruptor. So what this means is that it's a compound that affects the human hormone system. So this includes hormones that are used for reproduction and as well as sexual development, and this is done by its capacity to mimic estrogen. So this could alter your reproductive functions as well as alter puberty. So temperature also appears to be a factor with exposure to BPA. So some studies have shown that to prevent BPA, it's best to avoid heating polycarbonate plastic food containers in the microwave, as heat breaks down these materials, making and allowing more BPA to seep into your food. So the second topic that I'd like to talk about is plastics in the environment, as well as biodegradable polymers. So we all know that plastic is harmful to the environment as it's normally non-biodegradable. So it actually has the ability to withstand water and withstand microorganisms, which leads to the accumulation in landfills. And we know that this isn't good, so we see it now accumulating in other places as we're running out of space, such as in our oceans or in our communities. In landfills, plastics make soil less fertile, and overall it's harmful. And we know that in oceans, plastics harm marine life and harm their ecosystems. So you might ask, what can we do about this accumulation? So an aspect of polymers that's being explored is the biodegradation of polymers. So biodegradation is done by natural polymers, which are organic and have the tendency to decompose. They receive help from bacteria and fungi, which help this process along. Another way it could be done is also through the degradation of light, which is known as photodegradation, but we will not be focusing on this. This decomposition is done by slightly altering natural polymers or using them in a mixture with synthetic polymers to make them absorbable in the environment after a predicted amount of time without harm. So the predicted amount of time is key because we do not want these products degrading before we're done with them. And this is sort of an issue for some people, just sort of the timeline. They want to make sure that it can be a predicted amount of time. So when ready for degradation, a product is attacked by the microorganism at the surface. Once biodegradable fragments are removed, the product becomes more open and easier to pull apart. So what actually degrades the product is the enzymes produced by the microorganism itself. So since natural polymers have been on our Earth for millions of years, these microorganisms have evolved to develop enzymes, and they then have the ability to degrade the target structure. So although this is a great solution, it sounds like, there are some issues as nothing is perfect. So there needs to be certainty that no additives will be added to the polymer and that they're not toxic, since all material will be returned to the earth. And you might believe that the environmental impact of this degradation is low. However, there are aspects of this that could be argued. So when in unsuitable conditions for biodegradation, biomass such as methane and carbon dioxide are actually produced, and as we know, these are greenhouse gases and they're not good for our environment. And they contribute to global warming as well. So this can happen when a biopolymer is placed in a condition such as a landfill where there's a lack of oxygen and water. And one other downfall is that biopolymer, when it's mixed with other polymers in a place such as a recycling facility, then it's considered as a contaminant. So landfills must then be redesigned to allow biodegradation to happen naturally. So that is all the information that I have for you today. So thank you so much for watching my presentation, and I hope you learned something new today.